Okay, hello everybody, what's going on? This is Mohammed. Welcome to another video. In this video, I'm going to teach you how to find the volume of revolution of a curve about an axis that is not the x-axis, that is not the y-axis, but rather a random axis like y equals x in this case here, okay? And in this video, I'm proposing three different solutions, and actually you can think about many other solutions. Okay, one way to think about it is to try to rotate the curve until the axis of rotation is of revolution, I'm sorry, is the x-axis. Okay, so we can rotate it minus 45 degrees to the right. Okay, so that would make it a trivial problem. Okay, but again, I guess the curve that is going to result from rotation is not going to be an easy curve as well. Okay, so in this video, I'm proposing three good solutions, and the idea is to try to test your mathematical skills to find the volume of revolution of a curve about an axis that is not horizontal, that is not vertical, but rather inclined like y equals x. Okay, so let's start with the first solution. The first solution is basically I'm trying to slice the area under the curve, okay, that is bounded, okay, between the curve y equals 4x minus x squared. Okay, let me use some colors here so you can guys follow me. Okay, so I'm trying here to, this curve here, okay, I'm trying to slice the area that is bounded between this curve and the y equals x, basically, which is this one here, okay, into slices that when revolved around y equals x would generate disks of radius L, okay? And so what I did here, I assumed, to do this, we're gonna face two problems. Okay, that the integration is not gonna go from 0 to 3, but rather from 0 to 2, and then from 2 to 2.5, as we're gonna see in this solution. Why? Because we have basically two volumes, okay? And if you pay attention to the yellow region here, when you slice it into disks and revolve those disks around y equals x, that would generate a whole cylinder, which is straightforward. But if you look at if you pay attention to the green part, now the disks are not bounded, okay, between the curve and the axis of rotation or revolution, but rather between the curve and between the curve and itself. Okay, so in that we have to find a difference. Actually, the disks are not going to be like complete disks, but rather they're going to be rings. Okay, so we have to account for the outer radius and the inner radius. Okay, to calculate, for example, actually for the volume. Okay, so what we did here, I assumed a point, okay, which is this point here, x for A, which is point A, x, any point on the curve that changes actually between 0 and 3. Okay, so since, okay, the equation of this curve, I'm sorry, is 4x minus x squared, so the coordinates of the point A is going to be are going to be x and 4x minus x squared, so that's A. I will also assume a point on the axis of revolution that is basically the intersection of the line that is perpendicular that passes through the point A and also perpendicular on the axis of revolution. I assume that as B, and since B is happening on y equals x, so x, the x coordinate and the y coordinate are equal, so I assume that as A. Okay, as you can see here, I have assumed that the x coordinate and the y coordinate are A and A. Now, how can we find the coordinates A and A? So what we did here, we know that the slope, since, okay, this line here, the slices are going to be perpendicular on the axis of revolution, so their slope is going to be -1, because the axis of revolution, which is y equal x, has a slope of 1. So all the slices are perpendicular to this axis of revolution, so their slope should be equal to -1. So this is exactly what I did here. I calculated, okay, the slope, okay, between the points A and B, okay, which is basically 4x minus x squared minus a divided by x minus a. That is going to be equal to minus 1. And from that, we can calculate for the value of a, which is going to be x divided by 2 multiplied by 5 minus x. So in that way, we can know the coordinates of the point B. So B is now has the coordinates of x by 2, 5 multiplied by 5 minus x, and the y coordinate is also going to be the same thing. Now, why are we calculating the coordinates of A and B? Because we want to calculate for L, which is basically the length of the disk, the length of the radius of the disk. Actually, when this slice revolves around y equals x, it's gonna form a disk whose radius is L. So we need to actually d squared. Okay, so d, and we need to calculate for d squared. Now, so this is regarding, okay, the first volume. For the second volume, the slices, they're not bounded, okay, between the curve and the axis of revolution, but rather between the curve and the curve itself. Okay, so what we did here, I assumed the same point, which is A, that is moving on the curve, and also another point, which is C, whose coordinates is B and 4B minus B squared. And again, I benefited, okay, from the fact that the slope between the slope should be equal to minus 1, which is perpendicular on the axis of revolution, to calculate for the coordinates of B. So again, we can benefit from that as well. The slope of the points A and B and C is this one, which should be equal to minus 1, and from that we can calculate for the value B, which is 5 minus x, and from that we can determine the coordinates of C. So now we know the coordinates of A, we know the coordinates of B, we know the coordinates of C. So now we can calculate basically the radius of revolution in the yellow region. Okay, if we R, what is R? R is basically the distance between the point B, which is moving, by the way, and the origin. Okay, so if we calculate that, that is going to be equal to twice multiplied by x squared multiplied by 5 minus x all squared divided by 4. How did I calculate that? It's basically a different, it's the distance between 2 points, between the origin and point B. And since we know the coordinates of point B, so again, we can easily calculate for the distance squared, okay, between the origin and point B. And from that, we can calculate for R by taking the square root of that. Okay, so that would give us R equals 5x minus x squared divided by the square root of 2. And from that, we can differentiate both sides. So that would give us a relationship between dr and dx, because basically we are going to integrate through the axis of revolution, which is y equals x. It's not the x-axis. If it is the x-axis, it should be dx. If it is the y-axis, it should be dy. But here it is another axis, so it should be dr. Dr is related to dx using this relationship here. And then we need to know where to stop to calculate for the first volume, and basically we need to stop at the point that makes a perpendicular distance with the axis of revolution, which is going to be actually 2.5. Okay, so the yellow region can be traced, okay, by changing x, okay, between 0 and 2. So if we change x between 0 and 2, we would account for the first volume of revolution, which is the yellow region here. Okay, so revolving the yellow region here around or about the axis y equal x, okay, would be traced by letting x change between 0 and 2. Okay, how did we get 2? Basically, you need to see where the perpendicular at the point 3,3 intersects your curve. So it will intersect it at 2, okay, which is basically the maximum point here. Okay, and then for the green region, we need to let x move between 2 and another point. it doesn't have to go to 3, but to a point in between. How can we know this point? We need to basically find the derivative of the curve and equate that with -1. So if we do that, that's what I did here actually. I took the curve itself, I differentiated it and equate that with -1, and that would give me 2.5. So basically I need to stop at 2.5 to integrate between 2 and 2.5 to get the volume of revolution of the green area there. Okay, great. Now we need to calculate for D1. D1 is basically this the distance between A and B. Okay, so if you calculate that, that's going to be half x to the power 4 minus 3 x to the power cube plus 9 by 2 x squared. And again, you need to also calculate for D2. What is D2? D2 is the distance, basically. I'm not pointing this here in the figure, but it is basically this distance here, okay? This distance is basically D2, okay? D2. So what is D2? D2 is the distance between C and the axis of revolution, the perpendicular distance, of course. So if we calculate that, that's going to be 1/2 x to the power 4 minus 7x to the power 3 plus 69 divided by 2x squared minus 70x plus 50. Okay, now basically we can go ahead and calculate volume 2 as pi multiplied by multiplied by the integral from 0 to 2 of d1 squared multiplied by dr actually. And what is dr? We need to substitute dr here from as 5 minus 2x divided by the square root of 2 dx. Okay, how did we get this? Basically from here. Okay, good. And then we need to, if we do the integration, it's going to give us the value of 116 pi divided by 15 pi, 15 the square root of 2. And how do we calculate volume 2? Volume 2, basically, we need to calculate, to integrate from 2 to 2.5, and I have explained how we got 2.5, of d1 squared minus d2 squared. The outer radius, the squared, minus the inner radius squared. And of course, dr, and we need to substitute 5 minus 2x divided by the square root of 2 dx instead of dr. If we do this integration, that's going to give us 11 pi over 30, the square root of 2. Now we have the two volumes. What we can do here, we can add the two volumes to get the total volume, which is 81 pi divided by 10, the square root of 2. This is this problem is very interesting, and it is not an easy task to do actually. But now let's do some tricks. Okay, what we can do here is we can calculate for the centroid of the region. Okay, so the whole region here, okay, that is bounded between the curve and the axis of revolution, we can go ahead and find the centroid for that, and then the volume is going to be equal to the area exactly that we can get through integration. And then this area is going to be revolved around the axis of revolution, okay? The volume is going to be equal to the area itself multiplied by 2 pi r, where r is the distance between the centroid of this region and the axis of revolution. So this is exactly what I did here in the second solution. I have two curves, the curve itself, which is 4x minus x squared here, okay, and the axis of revolution, which is g of x equals x. I calculated, okay, the area under that is bounded between the curve and the axis of revolution, and I found that to be equal to 9 by 2. And then I calculated, okay, the x-coordinate of the centroid, which is 1 by a, the integration from 0 to 3, x multiplied by f of x minus g of x dx, that would give me 3 by 2. And the y-coordinate of the centroid, which is 1 over twice the area, a, the integration from 0 to 3, f of x plus g of x, f of x minus g of x dx, that would give me, 12 by 5. Now we know the coordinates of the centroid, so we can go ahead and find the distance between the centroid and the axis of revolution, and we can benefit from the formula for calculating the distance between a point and a line to calculate the distance between the centroid and the axis of revolution, which is basically 9 divided by 10, the square root of 2. And then we can go ahead and apply, calculate for the volume as 2 pi r multiplied by the area itself, and that would give us exactly the same answer. So this is a shortcut, and it is a very smart idea, yes, okay, but I mean the idea of this question is to test your mathematical skills to find the volume of revolution about an axis that is not horizontal, that is not vertical. And I'm proposing also a third way here, which basically you can slice, okay, the area not vertically or perpendicularly, okay, I mean vertically on the axis of revolution, but rather horizontally, okay, so parallel. Your slices are going to be parallel, okay, to the axis of revolution. So if you revolve these slices, they're going to generate cylinders around the axis of revolution, okay. So you need to let, and the slices are going to now change between a value here between 0. So I mean the x has to change now between 0 and a particular value between 0 and 3, which basically can be obtained by differentiating the curve and equating that with 1, okay. So that's what we're gonna do here. Again, I will assume that the point A here is x 4x minus x squared, okay, which is basically any point on the curve, this one here. I will assume B, any point on the actually not any point, it's the point that is that if you draw a perpendicular line from the point A to the line of to the axis of revolution, it would intersect, okay, the axis of revolution at point B. And because the equation of the axis of revolution is y equals x, so the coordinates of B are gonna be A and A. So to calculate for A, again, we need to find the slope between the points A and B and equate that with 1. That would give us the value of A. So now we know the coordinates of the point B, 3 minus x, and 3 plus 2x minus x squared. So now we know the coordinates of A, we know the coordinates of B. Now we're left with the coordinates of C. What is C? C is a point on the curve itself. So I will call it B, okay, the x coordinate, and of course the y coordinate is going to be the substitution of B into the equation of the curve, which is basically going to give us 4b minus b squared. Okay, so now how to calculate for B? To calculate for B, again, we need to find the slope between the points A and C and equate that with 1 as well. Okay, so this is exactly this is exactly, actually point C is not here, okay. So if we calculate for point C, it is going to be okay, so basically we can calculate for the point B by calculating the slope between the point A and point C and equating that with 1. And hold on, let me find the coordinates of the point C. The coordinates of the point C are the following. Now, why do we need the point C? We need to calculate for the distance D, okay? So to calculate for D, and I have calculated that here, it is going to be equal to 2 multiplied by 2x minus 3 all squared, and from that we can calculate for D. Okay, how did I calculate for D? You need to know the coordinates of A, which we know, and the coordinates of C. How do you calculate the coordinates of C? You need to find the slope between A and C and equate that with 1, and that's how you get the value of B, of course. And from that you can calculate for D and D squared, and from D squared you can calculate for D. Now, you need to calculate for L. What is L? It's the distance between the slices and the axis of revolution. And how do you calculate that? You need to calculate the distance between the point A and a line, which is y equal x. So you can benefit again from the formula between the distance of a point, between a point and an axis, okay, which is L here, which we found to be 3x minus x squared divided by the square root of 2. From that, we can differentiate both sides and get the relationship between dl and dx. D squared again, we can solve for it. And then the volume is going to be equal to 2 pi multiplied by the integral from 0 to 3 by 2. How did we get the point 3 by 2? Actually, we differentiated, okay, the curve and equated that with 1. So that would give us 3 by 2. So we know that we need to stop at 3 by 2, okay? So the volume is going to be equal to 2 pi multiplied by the integral from 0 to 3 by 2 of 3x, which is L, 3x minus x squared divided by the square root of 2, that is L, and d is basically the square root of 2 multiplied by 3 minus 2x, and then dl is this one here, related to dx. So the square root of 2 can be cancelled, can cancel with each other, and then you're going to be left out with this final formula here. If you do this integration, you're going to get the same exact result. Well, sorry for the long video. I just needed to put everything in one place. If you guys liked this video, hit like and don't forget to subscribe to the channel. Thank you for watching and see you in another video.